Hello, welcome back to the channel. So let's continue our previous discussion on separable differential equations and let's solve this differential equation over here. And in this question, since we are not given an initial value, we'll add the constant of integration at the last. So our final answer for the function will have the constant of integration, right? So let's start solving this differential equation over here. But before we solve this differential equation, I will highly suggest you to first watch my previous videos on separable differential equations if you have not watched those videos in order to get the full context of this video over here. So in order to solve this, let's first write the differential equation again. So this differential equation over here is basically x e to the power x square minus log y square. And let's simplify the right hand side first. So we can write this as simply dy by dx equals x times e to the power x square upon e to the power log of y square, right? Because e to the power a minus b is basically e to the power a upon e to the power b, right? And now you know that this expression is basically e to the power log y is basically y square. So now this would be dy by dx equals x e to the power x square upon simply y square. And now we can easily solve this differential equation over here by separation. So we can separate the y variables on the left hand side and the x variables on the right hand side. So it would basically be y square dy equals x e to the power x square dx in this case. And now you can take the integral on both sides. If you take the integral on both sides, the integral of y square is y cube upon 3. The integral of x e to the power x square is, you can use substitution to solve this. You can use your u function to be x square. And then you can solve for this indefinite integral, right? And if you'll solve this indefinite integral, you'll get 1 by 2 e to the power x square. You can also confirm that if you take the derivative of this expression, you should get x e to the power x square, right? So if you take the derivative of this expression, so the derivative of e to the power x square will be e to the power x square. And then you'll take using the chain rule, you'll take the derivative of x square, which is 2x. So e to the power x square times 2x, 2 will cancel out and you'll get x e to the power x square, right? And then after getting rid of all the indefinite integrals, you'll also add the constant of integration. So now in order to get the final answer, let's express our function in terms of f of x, right? So let's have this equation at the last. And in order to do that, we can just move this 3 over this side. So it will basically be y cube equals 3 by 2 e to the power x square plus 3c. Since you know that c can take any real value, so 3c will also take any real value. So we can write 3c as again c, right? Because c is a constant of integration which can take any real value. So it would be basically y cube equals 3 by 2 e to the power x square plus c. Also, please note that for this change that we did over here, we just do this for simplicity, for simplifying our expressions, because we know about the constant of integration that our constant of integration can take any real values. So it doesn't matter if you write 3c or c, since you know that c always belongs to a real number, so 3c will always belong to a real number as well, right? And now you can take cube root on both sides. If you take cube root on both sides, you'll get your final answer, which would be cube root of 3 by 2 e to the power x square plus the constant of integration. So this would be your final answer to this differential equation over here. So that was a simple problem. You just had to simplify the right hand side and separate the similar expressions on each side to get the final solution to your differential equation. So that's it for this video. Again, feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.